Hi everyone. So now I would like to talk about projectile motion and basically projectile motion examples. Before directly going to projectile motion examples, I would like to take a step back and review some facts about motion in general. We know that if an object moves and nothing interferes with it, no force, nothing whatsoever, it keeps going with constant velocity. So if I have velocity of v here, if nothing interferes with the velocity of this object, this keeps going. Let's say we are in outer space. If I throw something towards the left or right or up or down or whatever, it just keeps going on a straight line. That's Newton's first law. Now, we also said because of Earth that we live on, or because of if we would live in any other planet, because of that body, that huge mass, there is gravitational due to this mass that draws everything towards its core, towards its center. For Earth, it turns out that this number acceleration is 10 meters per second squared. So in every single second, if something is thrown upwards, its speed gets decreased in every second by 10 minutes per second. So if I throw something up by 40 meters per second, after 1 second it becomes 30, second becomes 20, third second 10, fourth second it stops, the velocity is 0. Then because of Earth, it moves backwards by 10, 20, 30, 40 backwards till it hits the ground again. So this is a free fall motion, and basically this is just because of this is the interference of Earth on the motion of vertical motions of objects. So these are the things that I would really like to everyone to understand before I move on with another example. So essentially, and the other thing is that this is an accelerating motion. We have an acceleration motion along the vertical direction, but acceleration is constant number. Acceleration means change in velocity. Of course, velocity is changing at any time. You can see 40, 39, 38 till we hit 30, till we hit 20. We hit 10, we go to 0, then we come back on Earth, towards Earth, and then it speeds up after, when it's coming down. This is changing in velocity, which means acceleration. However, this number of acceleration is constant. So along the x-axis, we have constant velocity. Along the y-axis, we have constant acceleration. How much is the acceleration? 10 meters per second squared. This 10 meters per second squared is constant, which means that it's not like one time it's 11, one time it's 5, one time is like 0.2. It's constant 10 meters per second squared, but it's accelerating motion, which means that it changes the speed accordingly. How much is the change in the speed? 10 meters per second in 1 second. So in each second, it either adds up to the previous speed by 10 meters per second, or it takes off of our speed by 10 meters per second. However, still this number of acceleration is a constant number. It never jumps to 15 and then comes back to 5 or whatever. It's just 10, but it's accelerating, which means that velocity changing, okay? So having said so, let's just do one example of projectile motion, just to make sure that we understand every bit of it, and it's basically it's going good. So suppose I'm saying that I hit a tennis ball and I hit it with a vertical speed of 20 meters per second. So VI initial of 20 meters per second, and the speed along the horizontal is, let's say, 40 meters per second. So this is Vx initial. Okay? And then it says we were asked about how long will the ball remain in the air. So we are throwing the ball like this. We're asked about the time that, you know, that this ball spends in the air, and also how far it will travel during this time. So how far it moves forward, this distance. So let's just be organized. All the x's together, all the y's together, and t time is the common factor for both. Actually, we are looking for it as well. So Vx initial is 40 meters per second. We also know that along the x direction, velocity is constant. We are asked about the distance x. We are also asked about t time. Initial vertical velocity is 20 meters per second. We are asked about the time again, just because time is common. I'll just write in both ways, in both x and y directions. And we also know that we have a constant acceleration of 10 meters per second squared. Okay, so let's just do this together. Now here, for the x, we have two unknowns. Like, we can't just do this. We better, because t is common in both, we better first solve for the x, for the time, and then once we have the time here, we can solve for the x very easily. So let's figure out the time through y, because if we can't figure out time through x, through the x direction, just because x is already unknown as well. So let's just do this together. So along the y direction, I know the initial velocity along the y is 20 meters per second, and I know it goes, the acceleration is 10 meters per second squared. So after 1 second, this 20 meters per second becomes 10. After second becomes dead zero, so it stops in the air. It's at this position. It's at the top, highest part in the parabola. And then after third second comes down by 10. After fourth second, it is actually 20. What I said, always we have, free falling motion is a symmetric motion. So if you throw it up by 20, it comes down by 20. So 1 second, 2 seconds, 3 seconds, 4 seconds. So t is 4 seconds. So the ball is 4 seconds in the air. Now we have 4 seconds here. We have 4 seconds here. So we have initial velocity. I know along the x direction is constant. I know the second. I can solve for the x. There you go. X over t. Just plug it in there. Vx. That is 40 equals x over 4. Hence, x is 160 meters. So x turns out to be 160 meters. So this is that, this is this, and we actually solved it. So it's not too bad at all. The other thing you could solve for, now that we are still in this, example, we can solve for how high this goes. So let's just let's see if we can do this. I know initial velocity was 20 meters per second up. So after 2 seconds, it stops because 20 becomes 10 and it becomes 0. And 0 is where it's at the highest point, right? And this is exactly what I told you. Let's solve for the highest y. So we have initial 20. We have another velocity that's 0. So we know the velocity changes. So let's figure out the average velocity. Whenever velocity changes, we have to solve for average velocity. 20 plus 0 over 2 gives me 10 meters per second. So the ball, on average, goes with 10 meters per second till it hits the highest point. Now, this 10 that we solved here is y over t. What is the t? The time that it takes to go from this point to the toppest part is only 2 seconds, because 20 becomes 10, then becomes 0. That's the highest part. So this t is actually 2 seconds. Y becomes 10 times 2, which is 20 meters high. Okay, is it all clear? Hopefully it is. So this is an overview. I'll talk to you later. Bye-bye.